yeah, so that's the schedule for the next few days. Yeah, I'm gonna try to get those review solutions up sometime today or tomorrow. And then, yeah, also, I know I'll talk a little bit more about the final project at some point. But yeah, you guys should find the PDF about that on Canvas and start working on that. You should be doing everything in the spreadsheet software. You shouldn't be using your calculators or whatever. You can use the computer to do everything for you. Question?
So I was just doing the final project in Excel, and I did like random numbers. Then every time I did the other calculation, like finding the average or something, all my other numbers would change. Like every time I clicked out of it. Is that supposed to happen? When you do random numbers, I just run my calculators.
Mine did the same thing, so I would copy and paste them and then repaste them, so that way when you select them, they don't keep changing.
So
I see.
the writers of the 1070 or the newer edition book are of the opinion that Excel is a subpar statistical software case.
Do they have a suggestion for something else? Or?
No, but
Okay.
also the Excel they use is obviously from like 1960s.
Right. Yeah, I mean, my beef with Excel is that it costs money, but I mean, Google Sheets can do all the same things. There's also open source versions that do all the same things. Definitely serious statisticians don't really use Excel though, because programming languages are more powerful than that. But yeah, any other questions? Let's get started. Okay, so let's start with this problem that we had last time, this problem 1. So last time we talked about parts A and B. We found the standard errors and we found that confidence interval. What about part C? Okay, so before we found a confidence interval for the proportion of bets that do treat large animals, last time, so we found a proportion of bets that don't treat large animals. Now I want to find a confidence interval, the proportion of bets that do treat large animals, okay? And so the question is, when we switch what we're doing, we're basically switching what we're calling a success from not treating the large animals to treating large animals. How does this affect the width of our confidence intervals? In other words, how does it affect that margin of error that we had?
Will it maintain the same size it was initially because you're just switching the p-hats?
So Stephen's suggesting that it would be the same length. That's solution B. Does anyone else have any thoughts? Do we agree or do we disagree?
Resounding maybe.
So by show of hands, who thinks it would stay the same length? Okay, so we got 4, 5.
Makes sense.
Show of hands, who thinks it would not stay the same length? So about a third of the class raised their hands at any point. How about Laura? Why do you think they would change length?
Because we had that equation for the p-hat, and we're adding a specific number to that or subtracting it. So
yeah, so let's remember a formula for the confidence interval. So it's p-hat plus or minus the square root of p-hat times 1 minus p-hat all over n.
yeah, so we have, so isn't z stars in there?
Oh yeah, sorry. Should be a z star there. Yeah.
So you said that the standard error will always stay the same no matter what, but with the p-hat, if we have a different number, then it's going to be.
Yeah, so Laura's argument is that we're changing what p-hat is because we're changing what we're calling success. So that definitely does change p-hat. I think Allison, did you raise your hand that it would not change?
Well, just because even isn't the
so this thing determines the length of the interval.
And then Z star be the same, because it's still 95% confidence interval?
Yeah, we're not changing Z star at all. We are changing P hat though. So what's going on there? I think you were on the right track, right? What happens when we switch the definition of success? We get a new P hat is equal to 1 minus the old P hat. So if we plug it into here, we get 1 minus P hat, and 1 minus 1 minus P hat, which just becomes P hat again. So at the end of the day, the answer is that it does not change. The answer is B. If we're changing the definition of success, we're just basically switching these two numbers. That does not change the width. Does that make sense? Good. All right, let's do the second problem then. So, let's get to the third problem. Let's look at potatoes. So we have this big truckload of potatoes, and before we make the long journey from the potato farm to the potato chip people, we want to make sure there's not too many defects in this truckload of potatoes. Okay, so also this states, unless there's clear evidence, this proportion of defects is less than 10%. We're going to reject the hypothesis that we're going to reject the shipment, basically. We're going to not ship the potatoes. Okay, so we take a random sample of 200 potatoes, there's 5,000 total, and we find that 12 of them are found to have major defects. Okay, so part A is asking about the null and alternative hypothesis. So let's take a couple minutes and figure that out together.